Hi, everybody. This is a video on section 5.2 subsets. Okay, so let's just take a look at the nomenclature first. Once again, you can just read this yourself, but this means is an element of. Let's say I have a set of one, two, three. Three is an element of, let's call it A, the subset A. Three is an element of A. It's just one, it's just a piece of A. Here's an example of not an element. Four is not an element of A. Since there's no four in the original A, so four is not an element. The empty set, you can write it like this, or you can just write it like this in two set brackets. We have it over here. It's just a set that contains no elements. So you just can't say it's blank. You do have to have the set bars or this like this symbol with the line through it. So both of those mean empty sets. Let's see what else we have. Natural numbers. By the way, if you're not sure what a natural number is, they're also called counting numbers. And counting numbers are, what you learn how to count: 1, 2, 3, 4 when you're a kid, and so on. Zero is not a counting number or not a natural number. When you're a kid, you learn how to count naturally from 1, 2, 3. You don't start with zero. And we talked about equivalent sets in 5.1. If the items, if basically equivalent sets are the same items in both sets. Well, equivalent sets have the same cardinal number. Let's put it that way. Equivalent sets have the same cardinal number. And here's an example. It's kind of weird. 1, 2, 3 is a set, and 4, 5, 6 is a set. These are equivalent because they both have three items in it. Not what the item is, they just have three items in it. And they're equal if they have the same items in it, same numbers. Last week we talked about this set: 1, 2, 3, and 1, 2, 3. These are equal sets because they both have one in it, they both have two in it, they both have three. Even though one is written twice here, they're still equal because they have the same numbers in both sets. Okay, so this week now we're getting a little bit more, not equal. And this one is a subset, and this is a proper subset. So let's talk about subset and proper subset. Let's say I have the set, I'm going to call it A, 1, 2, 3. And one is, if you just say one, that is a subset of A, right? Because you can take one out of there. 2, 3 is a subset of A because 2 and 3 are there, and you can put that. Now, a proper subset is the same thing as subsets. The only thing about proper subsets, 1, 2, 3, is not a proper subset of A. A proper subset has parts of it, but not all of the original set. Uh, by the way, 1, 2, 3 is a subset of A, but it's not a proper subset. It's I put a line through it because it's not a proper. Proper subsets don't have the exact same elements in it. I hope that makes sense. 4 is not a subset of A, right? Because there's no 4 in it. There's no 4 in it. So that's the difference between subset and proper subset. A proper subset, you can't have the exact same elements in it. In other words, you can't have two sets that equal each other. Universal set, the set of all elements. A prime is the complement. And let me show you an example of A prime. Get my pen. Let's say I have a universal set of 1, 2, 3, 4, 5, 6. And set A is 1, 2, 3, 6. Then A prime, if you look at if this is all the numbers that we have 1, 2, 3, 4, 5, 6, and A is 1, 2, 3, 6, then A prime is the numbers not in A. A prime is the complement. Things that are not in A, set 4 and 5, but they're in the universal set. So A prime is 4 and 5 because they're not in A. You can call it the complement. You can also call it a not. Not A, things that are not in A. This is the union. It's a marriage where both things come together, and this is an intersection. What's in common? What's in common with both? And I think that's it as far as the terminology for this week. Let's take a look at these. You don't want to go through all these. 16, if you look at 16, 16 is not an element. It's not in here. It's not an element. It's also not a subset. If it's not a subset, it's not a proper subset. 14 is an element. Right. Is an element. It's a subset of this set. And it's a proper subset. 1, 2, 3 is not an element. It's not a subset. It's not a proper subset. And so on and so on. So I think that's all we wanted to look at there. Let's keep going. Next page. By the way, the empty set is a subset of this. So the empty set is a subset, and it's also a proper subset. Here, the empty set is an element. It's also a set. It's a proper subset, and so on and so on. And that's 5.2, just the definitions. That was pretty quick. The main thing I wanted you to get out of 5.2 was the difference between a subset and a proper subset. If I have A equals 1, 2, 3, 1, 2, 3 is a subset of A. However, 1, 2, 3 is not a proper subset of A. You cannot, in a proper subset, you cannot have the exact same thing. 1 and 2 is a subset of A. 1 and 2 is a proper subset of A. The only thing that's not a proper subset is the exact same set that we're talking about. So that's what you should get out of 5.2. I hope this helps. You should be able to get through the homework. I'm going through the homework, and I mean, all you have to do is determine if it's part of the set or not. So 5.2 doesn't seem too bad.